So I'm using Blender 2.79b, and starting with a new file, go ahead and delete the cube that it comes with, drag from the top corner to make two workspaces, set this to the text editor, and can split this one down, one in rendered mode and one in solid mode. And then using the script that I wrote, you just copy paste, hit new down here, paste it in, and you can turn on line number, highlighting, coloring, make it easier to read, so that whenever it's run, then it goes through here and it adds all of the first you have to set the bottom to location rotation for the keyframes, and then just delete everything, run it again, and it sets up the scene completely with the render result, be able to scroll around the model, and it's complete with the hair. And if you go to texture, then it'll also show the hair particles that are attached to the model, which are done automatically. The script starts out with a bunch of config options. For example, do render is false right now, so it doesn't render all of the frames in the set. The frame first and frame last is the first frame and last frame to render, going through the sequence of frames, such as the camera moving around the model during the animation, which the program also sets up keyframes to move around the model. And then it sets the output path, the background path, and the model path, and I have them all set to this same folder named XSEDE, just D XSEDE, where models has the number of each of the models with the texture and models in each one. The backgrounds just contain HDR files with the 4K HDR backgrounds, which I got from HDRI Haven. And the output contains the folders that whenever the render is true, then it'll output all of the images from each frame to separate files. So the model number can be changed here, and this is the number 30 model, which is why it imported the same model. And then the face texture name, hair texture name, will be in the XSEDE models 30, which is the face BSM ALP PNG, and the face hair mesh PNG or 3ds, and the hair parts BSM ALP ftext.png. And I need this because, for example, this has face hair 3ds, which is different from face hair mesh 3ds, and face BSM ALP ftext.png. This one has the ftext right after this, like this one, and going back to this one does have the same hair texture name, so it's important to vary them depending on the model for each one. And then the hair count and interpolate hair is for the specific settings for the particle system I use for the hair. For example, the hair length is how long the hair is, and the hair number is how many hairs there are on the model. And of course both of those are controlled by the config options here, and also the hard-coded settings down below. Setting up the camera automatically, the program adds the camera at the origin, selects it, and sets it as the active camera, so the renderer knows to use that camera only as the current one. It sets the current frame to the first frame that was specified in the config options. Then it goes through 5 or 6 different positions, rotates it, moves the camera, inserts a keyframe on the timeline, and then moves 20 frames to the next one. So each position has 20 frames. And you'll see if you go to the camera view, then as you move, then it'll move along to one of the keyframes. So it sets a keyframe at the first one, moves to the next keyframe, and sets the next keyframe. So the timeline interpolates between the positions and the locations and rotations for each of the positions that are specified in this section of the code. And at the end, it'll deselect everything else. For the eyes function, it selects object 7, which is normally the eyes on each model, and then it adds a modifier, which is the subsurface sampling. So for example, the eyes look very rough, and if it goes up to a higher subsurface sampling, then it makes it a much smoother surface for the render. And that same subsurface sampling is applied to most parts of the model for a better render result. In the hair particles texture function, it takes in a parameter of the model number, and it selects object 9, which is normally the hair in most of the models. It adds the subdivision surface, and then it sets up a particle system, which is all the different little particles that come off of the surface, which are controlled with the hair count and interpolate hair, which if the hair count's lower and the interpolate hair is down or false, then the render might be a bit faster. Then also create a new hair material, which it'll create a hair material named hair material, and then it'll try to apply it to the hair variable, which is the object 9. And then after that, it uses the node editor to create all of the different nodes and links in the tree to create the texture that will be the part of the final render result. So for example, the image texture is black here, but the actual final render result is much more complex because of the node editor. So I've opened the node editor for the hair, and this code automatically does all of this. It creates the image texture, it's bright contrast, and then all these 4 hair shaders, 1 for transmission and 3 for reflection. So for all the depth and specularity on the hair. And then 3 mix shaders, which just mix them together at different factors to the material output, which is the render result. So that's what all this code does. It just adds each of these nodes and adds each of the links between them. So running the script, it doesn't position any of these nodes. It just adds them all in the same spot. And this is an example of what the program actually does. It doesn't reposition any of them to like where it would be visually obvious that each thing is connected to the next. It just knows that each thing is connected due to the node tree having the links all saved. Also the same with the skin. It does the image texture into a diffuse shader out to the material output. Which is down in the add skin texture. So it goes through and checks for objects that are the skin. There are multiple objects that are the skin that are all different numbers. So it takes the first object, which is normally the skin, and adds a subdivision surface to make it smoother. There's more iterations in the render, which is why the preview here looks much worse than the one out on the top. And then it creates one new material for that object, and then sets up the node tree, which is much simpler, and it loads the image from the configuration and adds the links. And then there's also a set of other objects that are hard-coded in to specify which objects are the skin and which should have the same texture as the face, or the same image applied to each one. And then for the rest of them, it adds the subdivision surfaces and adds the material. At the beginning, there's also another object on the chest about the same position of this one, and deleting it has no effect on the final result, so I delete it with every iteration of this. In the add masks, there's the compositor, which is part of the Blender render layers, and it adds a pass index to each of the object in the scene, so that the renderer, every time it renders something, then it'll also use this pass index right here to group them into masks, so that whenever it's outputted, for example, using the number 31 again, it'll create this mask since it combines all of the masks for that one, it combines 2 of them for that one, and it just uses the face mask for this one. But normally it will output something like this, so the holes need to be filled in with the script later. So this is how it automatically sets up the nodes in the compositor. It's a bit convoluted, so I'll try to explain it. The render layers is basically just the output of the render, with the image being saved as a file output. So the index OB is the index of each pass over an object. So like I have it so the hair is index 1, all the skin in the face is index 2, and then the other skin is index 3, and that's these 3 ID masks. So then the alpha convert turns them into the black and white images, and I have them saving as the hair, face, skin, and the background. And any that I need to combine, I use a simple math to add them together. And in the case of the 2 background nodes, I just invert the colors after I add the parts that I don't want to use. So that inverts them and saves all 5 or all 6 of these images. So for example, this other model it would output these 6 files, for example. So 1 of the background, 1 of the skin excluded from the background, 1 of the face, 1 of the hair, and 1 of the skin with the face. So this is what the compositor is set up to do for each render. And then in the change background, there's another simple setup here, and it just sets it up so the environment texture goes to a background node, and then the background goes to the world output, so it has this environment texture wrapped around the whole scene. It also acts as the lighting for the scene, and it's just it sets up 3 nodes and 2 links, and then adds the image as a property to this node here. The clear scene, it just does what I can do. I just hit A and delete, and it just removes everything, so I can run the script again and everything comes back. Import model, it just uses the config options to find the models in here. So in the models folder, which is the model path config option, and the number of the model in the options, and then also the name of the file in the options, which is the face hair mesh in this one, or the face hair in this one, or the face hair in a bunch of them. Move center, it goes through all of the objects, or for example, import the model in the XSEDE folder for number 30. All of the models have this same problem at the beginning, and you'll see in the outliner at the top it has all these models, like 1 through 48 in this case, that are all these little pieces, and at the beginning I was just deleting each one, but since the names are so different, I go through and select any of these, which is the it's the clean artifacts. There it is. And then it goes through each object in the outliner and deletes anything with a name that has length less than 2. So it'll go through and delete all these pieces that don't matter. And then using the move center function, it'll select the rest of the model and then move it so that the whole model is at the center, is facing upright and facing in the positive X direction. So then at the end, the render NM function will set up the first and last frames of the scene so that in the timeline it'll go from 1 to 101 in this case, where I have it set up with these 6 different locations. So it just goes through each frame in the range, and it times each render since it doesn't output normally. In the window, you can do toggle system console, and it will show the output for the Python scripts and also some other things like the keyframe outputs and when it saves a file. And then this one is what actually starts the render, but I have it so the whole thing doesn't execute if do render is false as a config option, so it's much easier to debug since each render frame takes between 60 and 90 seconds usually. And then it'll say how long it took to render the frame, and then it'll move on to the next frame until there's no more frames to render. At the end, it just uses a combination of all of these different functions so that starting from nothing, it will remove everything, import the model, remove all the pieces, move it and recenter it, add all the different camera keyframes so that the camera actually does move around to generate different images each time. It will add the eyes, which at this point is just the subdivision surfaces on the objects, since I wasn't able to find an automatic way to add the eye textures. Add skin texture, takes in, or these 3 take the model number since they depend on different files inside of the folder. And then for here, in the number of backgrounds that are specified in the config, it changes the background to that one, and then adds masks with the run, so it generates a different file each time. For example, it's for this one it'll generate image starting with 0, number 1, and then image background 1, number 1, background 2, number 1, background 3, number 1. And if do render is true, it'll actually render it and then save it to that folder. And then this just prints out the time it took for the entire operation. For the number of backgrounds, it has to be less than, or has to be at most the length of this to change the backgrounds. It would just be in the XSEDE, the backgrounds folder, or any other path that's specified. It'll be one of these different HDR backgrounds. And for some of them, it generates these like little specks on the image just due to the lighting of some of them, like these little white dots. I'm not sure if they're visible on the video. So I have 7 of these saved, but I'm only using 4 for the best results because some of them do produce some undesirable spots on the image. For example, when choosing another model to do a run of, I'll choose this random model. I haven't used it before, and it has hair and the model and the face. So that go to the config at the top, put it as the model number, verify that the face texture is the right name, the face hair 3ds is the correct name, and the hair is the correct name, and it is the same in this case. So if I delete everything and run it, then it sets up this model, and in this case I'm not quite sure why this one isn't working. See, with this one, the object 10 is taking on the same texture as the hair, I believe, which is why it comes up with that. So each object is a little different with the way everything is numbered. So in another model, for example, the object 10 was actually the hair, which is why it took on the same hair texture in that case, since I have that set in the add hair texture or add skin texture. So it sets each one as a skin or as a object for hair to be loaded onto. So each object is a little different for the numbering, which is the main problem why it's not easily done to render all of these at the same time. So as long as each object in the set is labeled correctly, as in put in the correct set, like the skin or the hair, like which nodes to treat, and also the masks, the pass indices will be different for each model because each one has a different layer, a different object in front of each other. But as long as those things are taken care of, then the render should be pretty automatic. You just set the first frame, last frame, output path, choose the backgrounds, and then choose the texture names, model name, and everything, so that everything is automatic. Once all of the rendering is done and you have each frame rendered for all of the different backgrounds, so this is one of the backgrounds in this room, and this is another background in this room, and it keeps going on. It'll generate all of the masks so that at the end, for example, for a different model, the face is going to have holes in it because of one of the models comes up to this point where it actually should just be the bottom part of the skin. So I can use these two programs here and put them here. And this one, it will fill the holes in any face mask or the background skin mask, which is the same model, same problem. So running this fill holes will read it in as a binary array and then fill in the holes and then save over the image. So running this fill holes script, it'll fill in the skin. Same with the face, it didn't get to because I have it set to here. I'll switch over to this one, and since there's only one image, then if I run it, it'll get the face also. It'll fill in the hole right there. It's just a bit of tweaking for each different run of it. And then for the bounding box program, it'll use the face mask, and it will use the same number of it to generate a mask around, or a bounding box around the image, using the same position of the face mask. So it just uses a Python library to find the coordinates around this mask and place that box around the same portion of the original image. And this, for a large image set, doesn't take very long. I can run it on this one and see it generates 40 of them in just a couple of seconds. So each image will have the bounding box over the correct portion of the model. And of course, each parameter is easily changed, and the names of each image, which are changed in the compositor settings in the Blender script to what it should be outputted as.